Physics Penguin.
Hello and welcome to Physics Penguin's Guide to Contact and Non-Contact Forces. This week we will be looking at the most common types of force, discussing what they do, placing them into one of two categories, and thinking about how forces actually work. This is a great example of something where the more you look at it, the more detail you can see. So let's start by focusing on the general picture. What is a force? A force is just a push or a pull that affects an object. That's it. Different forces have different causes, but they all put a pull or a push on something. This means that forces tend to cause change. You would expect to see something happen differently if a force is acting. What do forces do? Forces can basically change the movement of something by changing direction or speed, or they can change the shape or size of something. If you blew up a balloon and then popped it, it will get bigger as the force from your breath makes it swell. Then it will blow apart as the force in the stretch balloon gets released in a small explosion. Now comes an important bit. Forces can be either contact forces or non-contact forces. What's the difference? Contact. Honestly, the clue's right there in the title. If something touches an object to pass on a force, that's a contact force. If the force acts at a distance from its cause, it's a non-contact force. Let's look at some examples to show the difference. When Percy the penguin waddles over ice, the ice gets his weight pushing down on it. If Wally the walrus chases Percy, Wally's weight acts on the ice when he's in contact. If the ice is thin enough, then Wally's weight will be enough to break it, and he will fall through. Thanks, global warming. The ice is feeling a contact force. If Terry the toucan was flying overhead, the ice won't feel his weight because he doesn't touch it. If he lands and is too heavy, then he too would fall through. The strange thing is that weight isn't a contact force. It's an attraction between objects that have mass. Mass is just matter or stuff. Every object has mass and attracts every other object towards it. On Earth, the Earth itself is really a big object, so the force of weight or gravity, as people call it, feels like it's just pulling you down all the time. But if you floated a football in a paddling pool next to the bottom of a massive cliff, very slowly the ball will float towards the cliff. Cool, eh? The moon goes around the Earth because the Earth's gravity pulls the moon towards it, bending its path into an orbit. The Earth in turn goes around the sun because the sun's gravity pulls the Earth into an orbit around it. In these cases, the Earth doesn't touch the moon or the sun touch the Earth, so we call these things non-contact forces. Punches and hits are contact forces. Crashes and scrapes are contact forces. Explosions where something gets knocked away are contact forces because a blast of air actually hits the person. What about magnetism? If you held two magnets apart, you feel either attraction pulling them together or repulsion pushing them apart. Magnetism is a non-contact force. Notice that the force is quite strong at short range but much weaker as you move them apart. This is normal for non-contact forces. If you double the separation, you usually quarter the force. Electrical force, like in static electricity, also works at a distance, so this is also a non-contact force. You could use static electricity to make feathers rise up without touching them. People used to think it was magic because it seemed so strange. Frictional forces are when an object gets rubbed by a surface, or the material it is passing through. If you could see super close up, you would see that friction involves collisions between a surface and other molecules, So this must be a contact force. And finally, there is a big question. How do forces work? If you hold a brick above the earth and let it go, its weight pulls it down. How does it know which way to fall? Gravity isn't some big hand that reaches up and grabs it, so what's happening? Well, this is super important. We just don't know for sure. Science isn't a book of answers, it's a book of questions that's still being worked on. Each answer normally raises a few new questions, so our book will never be finished. But I'll give you a look at one possible answer that looks really good. You don't need to learn about this for real until A-level. In our brick example, there is something passing between the earth and the brick. Imagine a tiny particle that all objects with mass shoot out in all directions around them. When these particles hit another object, they form a tiny force. If this happens a lot, the force gets big. These particles must be weird because we can't detect them, and they could travel right across the universe and even through objects. We have called them gravitons, and at the time of recording this, physicists have not proved their existence. Maybe one of you could be the first to do it. Okay, now it's time to fill in the worksheet. It can be found in the description of this video and is a free Google link. Download it and have a go. Pause the video and I will go over the answers when you're done. Pause the video now. And welcome back. Let's have a look at question 1. It's a fan favourite table question. Let's go down the list. Gravity, non-contact force. Punches, contact. Crashes, contact. Scrapes, contact. Explosions, contact. Trickier though, it might just be air that hits you and knocks you back. Electrical force, non-contact. Magnetism, non-contact. And frictional force, contact. Pretty easy, eh? Let's try question 2. Why do your hands get hot when you rub them together? When you rub your hands together, there will be friction. When you rub two surfaces together, some of the energy comes out as heat energy. Friction turns movement to heat. Question 3 asks why don't iron filings jump onto a magnet when you enter the room? If you look back at question 1, we said magnetism is a non-contact force. So why does it not work at a long distance? Magnetism and all forces get weaker the further away two objects are. If you double the distance, you'll quarter the force acting. To be strong enough to overcome gravity and friction, the magnetism has to be at very close range. There's quite a bit behind this question when you think about it. Well done if you completed the sheet. Please subscribe to be notified of the next video in this series. This is Physics Penguin saying ta-ta.
Physics Penguin.